Dear student, today I'll be discussing about the electromagnetic induction. So what is electromagnetic induction? Before going to that, we have to understand what is magnetic flux. So magnetic flux, here is the expression of magnetic flux, phi is equal to BA cos theta. So magnetic flux means that number of magnetic field lines, perpendicular with the any surface area, okay. So that means let's A is the surface area here, and this direction is the normal to the surface, and theta is the angle between the normal to the surface and the magnetic field lines, okay. So phi will be BA cos theta, B for magnetic field strength, and these are the magnetic field lines, okay, part of B. A is the area of the coil, and theta is the angle between the this surface and the magnetic field lines. So this is the measurement of magnetic flux. So flux depend on three parameters: the magnetic field lines and the area of a surface and the angle between them. Okay. Now, whenever this flux getting changed, so flux may get changed for these three parameters, maybe for B, for A, or theta. So whenever this flux getting changed, we are getting the induced EMF, and for induced EMF we are getting the induced current. So this is the very brief about the electromagnetic induction. So electromagnetic induction, it's discovered by Faraday. So now I'll explain you the Faraday's law of electromagnetic induction. So we understand that whenever there is a change in magnetic flux in particular area or in a coil, so there will be a current. There will be induced EMF and induced current. Okay. Now, what Faraday told about this? So Faraday told that this change in this flux cause EMF, and first of all, so whenever there will be any change in the magnetic flux, it will cause the EMF. Second point is that second law of Faraday is that this EMF will depend on the rate of change of the flux. Okay, so that means EMF is change in flux with respect to time. Okay, so let the flux was phi 1, it's changed to phi 2 with time interval t. So rate of change of flux will be causing the EMF. So more the change of the flux, more the induced EMF. Okay, so this way he quantify the EMF. Now next is the Lenz law. So what Lenz told? Lenz told that the the induced EMF and induced current will oppose the change of the flux. So whatever the flux change is happening, so there is a cause. So induced current will be opposing this change in flux. That's why we are using the minus sign in Lenz law. Whenever there is a flow of current, so this current will produce because of the the change in magnetic flux, and they will be opposing each others. So there is a application like when we want to that identify the particular the direction of current in a coil. So we can identify that using the Lenz law. So let me show you the application of that. Suppose here is a magnetic bar, this is north pole, this is south pole, and this is the coil where current will produce. So when north pole is approaching towards the coil, so there will be current, and this current will be anti-clockwise directions. This current will be anti-clockwise direction. So that north pole will produce here. Okay. So the current will produce in the anti-clockwise directions. Okay. This polarity I will explain in another session. So this way, the north pole in front of north pole in the loop, the current direction will be anti-clockwise. Now, if we make this is the north pole, again the south pole, and if the magnet is coming away from the coil, then the direction of current will be the clockwise direction. So this is the application of the Lenz law. Okay. So other application we are having. So that we will be discussing in other session. So just focus on this is a part. Take it as a revision that Faraday's law of electromagnetic induction having two laws. First is that whenever there is a change in magnetic flux, we will be getting the induced EMF and induced current. And this induced EMF will depend on the rate of change of flux. Now, how can we increase the EMF or current? By increasing the magnetic intensity, or by changing the theta, or by increasing the area. Okay. So these are the parameter on which the induced EMF depends. And Lenz law told that the induced current will be opposing the cause for which it is producing. So Lenz law is supporting the conservation of energy over here. Okay. Okay. So that's it for today. Thank you.